I guess I don't have a specific agenda other than talking about the old finals. So if people don't have specific questions, then I can just kind of go through and give sort of my sketches of the solutions to some of the problems. Again, we have I posted the solution, the answer key on the B courses for both of the finals. So there's a 2012 one and then there's a 2011 one. In case we're wondering about like 2013, so last year I was on like partial paternity leave, and so it was taught by a different instructor then. So I didn't technically have his exam, but I didn't bother posting it because it's probably not going to be quite the same as my exam. So I can go through those, but probably more useful given that you have the solutions is particularly if they're like specific questions that you guys that people have already looked at and either found challenging and or didn't quite understand like why the solution was what it was, or the write-up didn't make so much sense to you. Then I think that's sort of the biggest value add for in terms of like using our time right now. But I think so. Let me start saying, does anybody have like a specific question that they want to talk about on either of the two finals? So I kind of suspected that the open-ended question would not get any responses. So maybe I'll start going through them, and then as we go through, talk about which. Mental health. Sure. Which one? So it's sort of more helpful if we have the which final are we referring to here? Oh, yes, that's a good question. So yes, you can use a calculator. In fact, well, not everybody's here. If I said that a calculator were required, and you can't use your like iPhone or your smartphone as a calculator because obviously you have other things on there, how many people would have a problem with that? Like basically, how many people do not have access to a calculator that is not their smartphone? Graphing calculator is fine. You can make all the graphs you want. So it looks like nobody has a problem with that. Okay, so I might actually make a calculator required just so that it just makes it a lot easier to write the exam. In particular, since we might have two versions. Okay, let me make a note of that. Sorry, so which exam were you referring to? 2011, question number 6. Okay. So this is the VSL question. Is that it starts off like Davis 2004 uses the emergence of the cancer cluster? Oh, okay. No problem. Oh, okay. So this is the one that has this is the steel mill, and I'm giving you the table, right? Okay. Yeah. So I mentioned on Friday that there should be one question that takes basically a table from one of the papers and asks you to interpret it. And so what this table does is it's coming from the paper where they're looking at those two counties in Utah. One of the counties has a steel mill operating in it that actually is responsible for like the majority of the air pollution in that county. And then the other county is kind of nearby but doesn't have, right? I think it's actually maybe it's a valley or whatever. So there's two geographic jurisdictions. One of them is the control valley that doesn't have isn't affected by steel mill's operation, and then one of them is the treated valley where the steel mill is running most of the time, but then it actually shuts down for a few months or maybe up to a year, I think, because of this labor strike. And so the table is basically reproducing, or the table reports like the main results from that paper. And the outcomes that they're looking at are basically sort of hospitalizations or hospital admissions for various respiratory diseases. So they have bronchitis and asthma among everybody, among preschool children, and then pneumonia among everybody, and among preschool children, and then other respiratory diseases. And so the key, I think the key to answering this question is just sort of a combination of A, understanding like what the paper is about, and so what they're trying to estimate, and then B, understanding basically how like tables tend to be organized for reporting regression results. So I know like it's been a while, but at the sort of early on, I think probably a little bit before the midterm, we actually, when we were talking about regressions, like we actually went through like one or two tables from a paper, like so we learned about linear regressions, and then one of the lecturers actually sort of threw up a table and just kind of said like here's a table reporting some results from regression, and here's how you interpret it. We haven't done that for a while, so it's probably useful to kind of touch upon that again. So if you actually, this is probably a good. I should actually hook up the laptop so that it's clear what we're looking at here. So typically for these types of tables, what you'll see is that there's like, obviously there's going to be rows and columns, and usually not exclusively, but usually like one column corresponds to one regression. So let me show you what's actually going on here. Okay, so this is the actual like. Okay, so this is the actual table that you see in the exam, and so basically, again, as I said, like usually it's going to be the case that one column in one of these tables corresponds to a single regression, and then each of the rows corresponds to like sort of a different coefficient that's coming out of that regression. One thing that you'll often see is that people are not going to report all of the coefficients in the regression. So you might have a regression where you have some outcome, so the outcome is y, and then you're regressing it on an x variable that is really sort of what we call like the variable of interest or the coefficient of interest. So it's like sort of the treatment that you're interested in estimating. So in this particular case, the coefficient of interest is going to be the effect of the mill operation on hospitalizations. So that's what this first row, or actually the second row, is here in this table. And then usually, if you're in a lot of cases, like you'll have a lot of control variables as well, right? Because you're trying to control for other observable factors that might affect the outcome. And typically, so this table is kind of an exception in the sense that like they are reporting many, if not all, of their regression coefficients. But typically, especially if you had like 10 or 20 control variables, you're not going to report all of the coefficients on those control variables because they're not really of any interest to the reader per se. I mean, the reader wants to know that you are controlling for those variables, but they don't care about what the actual coefficient is on that variable because they don't care about the effect. Like they're not interested in knowing what the effect of some random covariate, some random control variable is on the outcome. So typically, you'll see like only a smaller number, a smaller subset of the coefficients actually reported. In particular, like often you're not going to see the intercept reported because that's really not something that's like of much interest to anybody. But again, this table happens to be the exception. But they tell you what they're reporting. So this first column, what this regression is it's a regression of the outcome. So the outcome typically they'll tell you sort of at the top of the table. So here the outcome is bronchitis and asthma admissions for all ages, and then and it's for Utah Valley in the first column, which is that must be the valley that's actually affected by the mill. And so they've got the intercept. They have the variable that indicates whether or not the mill is open. So that's going to essentially be the coefficient of interest in this particular case. And then they have a bunch of different control variables. So they have an indicator for whether it's fall, whether it's winter, and whether it's spring. You can think of those as basically seasonal effects that they're trying to control for. And they tell you the coefficients on these variables. Although again, we don't really care about them very much. That's not the point of the study. They're just control variables. And they have this time trend as well. So we know that hospitalizations for bronchitis and asthma, maybe they're trending upwards, maybe they're trending downwards over time. Whatever the trend is, we want to be able to control for that. So they're controlling for that as well. Then at the very end here, they have this likelihood ratio test statistic that you really don't need to worry about. It's just a joint test for whether all of the coefficients are significant. But it's not important. So basically, most of the focus of the question is going to be on this second row here, which is the coefficient of interest, the effect of the mill being open. And then you can see, that's just a single regression. So then they have the second column is basically the same regression, but they've changed the dependent variable, the outcome. So instead of looking at hospitalizations in Utah Valley, which is the treated valley, now they're looking at hospitalizations in the control valley, which is Cache Valley. And so those would be like the first two regressions, and the next two regressions would be same outcome, but only looking at hospitalizations for preschool children. And then the third set of columns is like same regressions, but now the outcome is pneumonia instead of bronchitis and asthma. And so basically, they've got I don't know how many, over a dozen regression or a dozen different regressions that they're reporting here, and the difference is essentially always they're just changing the outcome and or which valley they're looking at. So the thing that's a little bit trickier about this table relative to maybe some of the other tables that you might see is that like they don't actually ever in this specific table they don't actually report that the sort of the final estimate that you would look at. So this is like this is basically a difference in differences design, and so we know that what you're going to end up computing is like the change in the change in the outcome for the treated area relative to the change in the outcome for the control area. And they never actually give you a single regression where they're combining the data from both the treated area and the control area together into like one sample and running the regression on that entire sample, right? So they don't actually give you a difference in differences estimate as like any one of these coefficients. You'd have to actually go through and compute it yourself by taking like the difference between two specific coefficients. So the thing is, the question I think is designed to kind of like guide you along that path. So the first part A says, according to the table, how much do bronchitis and asthma admissions for all ages change in Utah Valley when the steel mill is open? Is the change statistically significant? So you're looking, to answer the question, you say, okay, well, the outcome that I'm interested in is the bronchitis and asthma admissions. I want to focus on just Utah Valley. So conveniently enough, that's the first column. And then I want to know what the change is when the steel mill is open. So I want to look at the coefficient on the variable that tells you whether or not the steel mill is open. So that's 0.205 right here. One thing that I think we've mentioned at various points, but if not, certainly I'll mention it again now, is that if you have a case where your dependent variable, where the outcome, like the y variable, is in logs, so what they're doing is basically taking the number of bronchitis and asthma admissions and then taking the log of that and running the log of that on their x's and so forth, then when you see a coefficient on an x in that regression, you can interpret it as giving you the percentage change in the outcome. So in this particular case, then, since they're, it says specifically in the setup that the dependent variables are in logs, then you can interpret this like 0.205 coefficient as basically being a percentage change. It's actually an approximation, but it's pretty close. So what this is going to tell you is that bronchitis and asthma admissions in Utah Valley increased by 20.5% approximately when the steel mill is open. Yes, that is correct, which would be confusing, I can see. Okay, so yeah, so that would be, it should be 20.5%, or it should be bronchitis and asthma admissions increased by 20.5%. And then the question of whether or not it's statistically significant, we talked about basically computing the t-stat, and the rule of thumb is whether or not it's greater than 2.5 the value. Here it is, because you take the 20.5 divided by 0.07, you get a t-stat of about 3, so it would be statistically significant. So, so the first part, yep. So the statistic that you need is the t-statistic, which is the ratio of the coefficient divided by its standard error. And so in this table, and probably in any other table that you see up, that you might encounter, the coefficient is like this. The practice in the literature is you always like give the coefficient first, and then underneath in parentheses you put the standard error. So like in this specific case, the coefficient is 0.205, and then the standard error right underneath is 0.07. So it gives you your t-stat. So if you here it says 205 divided by 0.07, it's equal to 2.9, and then the question is whether or not that number is greater than 2 in absolute value, and obviously it's 2.9. So that would be your guide to whether or not it's significant. Okay, so that's like the answer to the first part. And then the second part is basically just the same thing, but it instead is asking about what happens in Cache Valley, which is like the control valley in this study. And so, you can basically just go, okay, well, now I'm just looking at the second column because that's the one that corresponds to Cache Valley. Here you have a minus 0.152 as the coefficient, and the standard error is 0.125. So the answer to the first part, again, this should be bronchitis and asthma rather than other respiratory, but the answer to the first part is that it would decrease by 15.2%. Then the answer to the second part would be, the ratio, is it statistically significant? So you calculate that ratio, the 152 divided by 125. That turns out to be about 1.2. Clearly it's less than 2 because to be 2, that coefficient would have to be about 0.250. So it's not statistically significant. And if you so it even tells you in the question, just in case you didn't remember the details, Utah Valley contains a steel mill, Cache Valley does not. So in some sense, that's kind of reassuring, right? Because this is running a regression using data from Cache Valley. the coefficient there is an indicator, or it's a coefficient on indicator for the time period during which that steel mill is open. But the steel mill isn't actually in that valley, right? So it's just defined based on dates. Doesn't actually indicate that there's a steel mill operating in that specific valley. And so you would kind of hope that you wouldn't find a significant effect of the steel mill in a different valley on hospitalizations in Cache Valley. And sure enough, you do not find that, in the sense that at least it's not statistically significant. Then the last part, I think, is sort of the, I don't think it's like super hard, but it is the trickiest part of this question, which it says, what is the diffs and diffs estimate of the effect of the steel mill being open on bronchitis and asthma? So this is basically the part that that requires you to sort of understand what's going on in the study rather than just like kind of interpreting the table, right? So even if you didn't really know anything about this study, but you kind of understood how to read the regression results, you could probably answer those first two questions. But the last part, you kind of need to understand, like, okay, well, Utah Valley contains the steel mill. The steel mill isn't operating all the time; it's only operating some of the time. Other times it's shut down because of the labor strike. And we're going to do a comparison between the change in the outcome, the change in hospitalizations in the affected valley and the steel mill valley when the steel mill is operating versus when it isn't, and compare that change to the change in hospitalizations during the same period in the control valley. So basically, the beta in both of these regressions. Sorry, can't really highlight a specific part because it's really just an entire image. But in both of the regressions, that beta 1, the mill open coefficient, is giving you the difference in hospitalizations between the period when the mill is open versus when it's not open. So that's like the change in y within or over time within like each of the two affected, or the two areas really. This is the treated area and then this is the control area. So you could think of each of these two numbers as being like the first difference in each of the areas in the difference in differences estimator. But then we know we need to take like the difference between the two differences. And so what you would do is take the difference between 0.205 and the minus 0.152, which would end up actually summing those two numbers because you're taking the subtracting off a negative number, and that would give you 35.7%. So again, the idea here is like, what you have here is like the change in y in the treated county. So this is delta y, that's going to be like y1t, we'll call it minus y0t, where this is sort of, so often we're thinking of this as being like the the post-treatment period here is period 1, and the pre-treatment period is period 0. Then you have the change in the control county, so we'll just call that y1c minus y0c. So that's the change in the outcome in the control county over time, during the period when the treatment is in operation versus when it's not. And then you're going to take the difference in those two things. So you're taking the difference between the delta yt and the delta yc. And so this is basically equal to beta 1 for, Utah Valley. And this one is equal to beta 1 for Cache Valley, because again, the beta 1, the coefficient on that steel mill operating indicator is just giving you the difference in the outcome between when the steel mill is operating versus when it's not operating, which is the treatment we're thinking about here. So that's the entire question. I think that the year that I gave it, there are also like some students who, if you go in and actually like do the write down the log of y is equal to beta naught plus beta 1x and so forth, and raise everything by e to the x and so forth, you can come up with like a more precise change, a more precise like percentage change than just reading straight from this coefficient and multiplying it by 100. If you do that, that's fine, but it's not necessary. Like, I'm not going to document any points for not doing that. Sorry, I'm not sure what was supposed to make get back now. Do you have to? You mean if you said like respiratory emissions increased by 0.205? Yeah, so you would need, like in this case, you would need to convert it into percentage. Because technically you say it's increasing by 0.205, but you're actually saying it's the log of the outcome is increasing by that rather than the outcome. So I mean, if there's a table where the dependent variable is in logs, like I'll note that in the write up underneath, so that should hopefully clear you off. But then I will expect you to actually do the conversion. Oh, sure. So I mean, if it were just so let's suppose that this was like it was just the raw number of hospitalizations rather than the log of hospitalizations. So in that case, I mean, it would just be more straightforward then, quite frankly, because you just say like, okay, other respiratory emissions increased by 0.205. It seems like it's unlikely that you would get a coefficient of 0.205 and that it would be statistically significant unless there were actually some rate or something. Like it would probably given to you in like rate of like per 1,000 residents or something like that, just because 0.2 of a single hospitalization isn't a very big effect. But if it were just in levels or in some sort of rate that was in levels, then you could just read straight off the thing and give the 0.205 instead of the 20.5% and the 0.152 instead of the 15.2%. Okay, are there other questions about specific questions? Jason? Yeah, so these ones are the ones that I think people tend to find difficult. Where's my 2011? Oh, sorry, the winner came out because it's already up on the other screen. Okay, so did you say you wanted a specific one or? Okay, yeah, okay, so this is yeah, I think it's definitely good to go over one of these two, just so, since you guys haven't done this yet. You haven't done like one of these specific questions yet. Okay, so this is asking about the Moretti and Nadell paper that looks at the arrival of the ships in Los Angeles or in Long Beach and uses that as a source of variation in air pollution levels. So the idea is like lots of ships arrive on a given day, that increases air pollution, and then maybe that's going to have an effect on hospitalizations. In fact, they do find that. And so the setup here is probably somewhat important just in terms of like making sure that you understand the research design. So again, like you're not